Good morning. Today, I will present SARL-STG, especially a wear reinforcement learning framework for spatial-temporal video grounding. Given a video and a language query, our goal is to find when the event happens and localize the referred target in each relevant frame. The key idea is to use spatial grounding quality as feedback to refine temporal reasoning. Spatial-temporal video grounding is harder than temporal grounding alone. The query may describe target, attributes, interactions, environments, and spatial relations, so the model must identify the correct object, understand the action, and track where it appears. If the predicted time interval is slightly wrong, the spatial module may see frames where the target is absent or semantically inconsistent. Existing methods usually make a trade-off. Single-stage models can be accurate, but are often dataset-specific. Two-stage pipelines are flexible, but temporal errors directly affect the spatial module. And LLM-based supervised fine-tuning improves semantics but still lacks precise grounding. The missing component is a feedback loop. Spatial failure should help improve temporal prediction. SARL-STG has three main contributions. First, it combines a pre-trained MLM for temporal reasoning with an open vocabulary detector for spatial grounding. Second, it introduces a dynamic reinforcement learning reward, where spatial grounding quality is injected into temporal refinement. Third, it builds STVG Wild, a diverse 220K sample training set. Together, these components produce strong and generous EVG performance. STVG Wild is built from multiple sources, including STVG, RVOS, VLT, TVG, TVG, and web videos. For incomplete annotations, MLLM agents generate or complete event queries. Timestamp expansion adds negative context, making temporal localization more discriminative. For boxes, a detector and tracker are combined to produce dense frame-level spatial annotations. The result is a unified dataset with query time interval and target boxes. The final dataset contains 220K spatial-temporal samples from 5 source families, covering more than 50 object categories. The scale and diversity are important. The model should not only fit one benchmark, but also learn robust spatial-temporal semantics that transfer to new videos, object categories, and query styles. The architecture has two modules. The temporal grounding module uses Q, 1.5VL to read the full video and query, then predict the event interval. The selected sub-video is then passed to the spatial grounding module. The spatial module uses query features, local frame features, and global MLLM video semantics to predict a consistent target to build cross frames. Stage 1 performs supervised fine-tuning on STVG Wild using temporal, box regression, and classification losses. Stage 2 applies GRPO on high-quality samples. The spatial module acts as a discriminator. When temporal is low, the reward focuses on correcting time. Once the interval becomes reasonable, the spatial I/O U-turn becomes stronger. This lets the model learn time first, then learn spatially meaningful boundaries. At inference time, SARL-STG first predicts the event interval from the full video and query. It then crops the subvideo and localizes the referred target in each selected frame. This walkthrough shows why temporal and spatial reasoning should interact. Temporal prediction controls what the spatial module sees, while spatial quality verifies whether the time interval is useful. SARL-STG achieves strong results using the same model without dataset-specific fine-tuning. On HCSTVG v2, mean TIOU improves from 60.4 to 64.2, and mean VIOU improves from 40 to 242.5. It also improves VIOU on both declarative and interrogative VIDST settings. These results show gains in both temporal grounding and spatial grounding. SARL-STG also transfers well. On STA-LAN-0 evaluation, it reaches 49.5 mean TIOU in 26.6.6 mean VIOU. The ablation study shows that supervised fine-tuning is a strong start, but dynamic spatial-temporal reward gives the best refinement. To conclude, SARL-STG shows 3 points. Spatial grounding quality can supervise temporal reasoning. Reinforcement learning enables progressive spatial-temporal refinement. And STVG Wild provides the scale and diversity needed for open-world STVG training. Thank you.